Now we'll continue with the cam diagram. Okay, my first question, radial follower. So in the question they mentioned about the cam with 3 centimeter minimum radius, the base circle radius they mentioned. So first I'll draw that 3 centimeter so make enough space here. Okay, you need more space here. S. Now draw 3 centimeter circle, which is the base circle of the cam. So it is 1, 2, 3. So measure 3 centimeter and place it conveniently so that your cam will be properly drawn at the center. So I did 3 centimeter circle. Now you have to show the initial position of the follower, knife edge follower. For that, what you have to do is, see, we are doing first question, that is radial follower. In radial follower, the axis of the cam and the axis of the follower are on the same straight line. So here, now this is the axis of the cam. Now I show like this. Now this is my initial position. Since it is a knife edge means its shape is V shape. The end of the one end of the follower is V shape. So this is your knife edge follower. Now this is the initial position. Now in the question it is mentioned that if the cam is rotating clockwise direction, so I will show the direction of the cam clockwise. Okay, the cam is rotating clockwise direction, as I mentioned as I mentioned before. When the cam rotates clockwise, your follower rotates, or we assume the position of the follower in anti-clockwise directions. So here now I have to show the outward outstroke, dwell, return stroke, and the second dwell. See, these angles I have to show in this circle. Now take the protractor. This is my center now, center of the cam. Okay, from the center of the cam measure angle 120 degree, because follower move outward through 3 centimeter during the 120 degree of cam rotation. So here 0 starts with 0 and mark 120 degree. Okay. From here, from center, draw one line. Don't draw a thick line because you have to erase later. Now from this position till here, this is 120 degree, that is outstroke, and from 120 to again 60, that is from 120 to 180 degree, that is dwell. So from this line, mark 60 degree. So this is my 60 degree. Then now join the center of the cam and this 60-degree point. Okay, so this is theta naught, that is theta outstroke angle during outstroke, and this is dwell, the first dwell, and after the first dwell is your return stroke, and the return stroke angle is 90 degree. So from this line you have to mark 90 degree. Okay, so from this position to this position it is outstroke. Join these 2 points, draw a thin line so that later you can erase easily, and remaining is dwell 2, that is second dwell. Okay, now I divided the 360 degree into different regions, that is outstroke, second is dwell, then return stroke, then remaining is second dwell. Okay, now the next step is, see, while doing the displacement diagram, the region, the outstroke region, you divide it into 6 equal parts. So same number of parts you have to divide here also, in cam drawing also, while constructing the cam you have to divide this outstroke region into same number of parts as you divided the displacement diagram. Okay, in displacement diagram I divided into 6 parts. If you divide 8 parts, then you have to divide here in cam diagram into 8 parts. Since I divided into 6 parts, so you have to divide here the outstroke region into 6 parts. So the total angle is 120 degree, and I am dividing into 6 parts. That is for every yes, 120 by 6.
120 by 6. You stop
Mathalikilla. Now this is my initial position. From here I have to mark at every 20 angles, 20 degrees you mark. So it is first region, 42nd, 63rd, after that 84th, 100, 5th and 126th. So I divided into 6 parts, outstroke region into 6 parts. So here also you draw thin line, don't make it very much dark. See, if you draw dark line, then your cam profile will not be visible in final sketch. Okay, so it is preferred to draw thin line. These lines are used to mark the trace point of the follower at different point. Okay, so now I divided this outstroke region into 6 parts. Next is dwell. Dwell in dwell region the follower will not move, so I kept it S. I divided outstroke into 6 parts. Next is dwell, and then I have to divide this return stroke into 6 parts. Okay, return stroke angle is 90 degree, so 90 divided by 6 is 15. So every 15 degrees I have to divide. So it starts from here. Please note, it starts from this point. Like this you have to mark the angle. So 15, 30, 45, 45 and then 60, then 75, 90. 1, 2, 3, 4, 5, 6. So I divided this also, the outstroke region also, into 6 parts. Then similarly join these 2 points. Yes. After marking these divisions, I divided outstroke into 6 parts. Then next is dwell. Then again I divided return stroke into 6 parts. Then remaining is second dwell. Okay. Now I have to mark the displacement of the follower at different instances. You take the reference of displacement diagram. Now this x-axis or the 0 line that shows the initial position of the follower. Now follower at this 0 angle, the follower is at initial position. Okay, when the angle increases, the follower move up. That is, at first division, the follower moved up to 1 dash. The second division, follower moved up to second dash, 2 dash, and at third division, follower goes up to third dash, like that, 4th dash, 5th dash, and 6th dash. So all these 1 dash, 2 dash till 6 dash you have to mark here in cam. For that you have to take the reference. Now 0 here, the 0 point on the displacement diagram that I represented here. This is the 0 point. Okay, this is 0. Now on the first point, this is my first line, second line, third line, fourth, fifth, sixth. How I divided the displacement diagram. Similarly, I divided here. So on the first line, I have to mark the displacement of the follower. Displacement of the follower is from initial position to first 1 dash. So take that distance, this distance. Okay, then from this position you mark. This is 1 dash. This point is 1 dash. Now you measure the distance between 0 and 2 dash. Measure this distance, and from here you mark that distance on the second line. Measure the distance between 0 and 3 dash, and on the third line you mark that distance. On 4th dash, for 4 dash you measure the distance between 0 and 4 dash, and on the 4th line you mark that. Similarly, 5th one. This shows the position of the follower at different angles or at different instants. Now 6th. Now here from the 0 mark 6th. Now I'll name these points. 1 dash, this is 2 dash, this one is 3 dash, 4 dash, 5 dash, and 6 dash. Now if you observe this displacement diagram from 6 dash to this one, that is dwell 1 region, right? Dwell 1 region, the follower will not move up or follower will not move down, so it will be stationary from 120 degree to 180 degree. So till 180 degree the follower will not move, so I will mark that point also. Measure this distance, and here from 0 you mark that. This is again 6 dash. Okay, 6 dash. Now you take the distance between 0 and 7 dash. 0 and 7 dash. Now from the circle, 0 circle, you mark that 7 dash point. Next, you take the distance between 8 dash. 8 is here, this point. You mark it on this line. Okay, now so in the same way you mark next point, next here, next, you mark here, you mark 11th point, and here this is 0 again. See, the follower again comes back to initial position here. From that position to again first 360 degree, follower will be at rest. So from here to here the follower will be at rest. It will not move up or move up. It will be touching this circle only. So no need to mark those points. Now we got before that I'll mark this. I'll give you the numbers. 6 dash, after that 7 dash, this point is 8 dash, 9 dash, 10 dash, 11 dash, and this one is 12 dash. Okay, so I mark all I mark all these points from displacement diagram. Okay, that is the use of displacement diagram. That's why first we'll draw the displacement diagram. We take the reference from displacement diagram and we'll mark in the cam profile. Now we got all the points. Now next step is you have to join all these points to get cam profile. Join all these points by freehand. It should start from here because follower will be initial position from this point, from 0. Yes, now marking all these points. The next step is you have to join all these points by smooth curve. You should start from point O. Next, 4th point, 5th point, and 6th. Okay, from 6 to 6, since the distance is same here, then I can use compass. I join 6 dash and 6 dash here. Next, from here join 7 dash, then 8 dash, 9 dash, 10 dash, 11 dash, and again back to 12 dash. Okay, now this is the cam profile. Now just darken this curve, these lines. Please use pencil. I am using pen because it's not visible if I use pencil in video. So this is the cam. Now again here also I have to move that because this is also part of cam. Okay. Now this is a cam profile, and that is what they asked in the question. now you have to give final touch. If you want, if you highlight this one, then no need of erasing these construction lines and all. And if you're not able to darken this cam profile, then you please erase or just erase these lines, extra construction lines. Okay, now we have to name the curves. The first curve, this curve is called cam profile, and this curve is base circle, and this is knife edge follower. This I am drawing because this is a guide that guides the knife edge follower. This is knife edge follower. Okay. This arrow indicates that the cam is rotating clockwise direction, because that is what they asked in the question. The cam is rotating in clockwise direction. So this completes your first half. That is draw the cam profile when the follower axis passes through the cam axis. Okay. The second part, the draw the cam profile when the follower axis is offset to the right by 1 centimeter. To draw this offset problems, the displacement diagram will be same, because offset doesn't affect this displacement of the follower. Okay, it will affect only the cam profile here. Instead of this follower position, it will be displayed. That is, in the question they told follower axis is offset to the right side. That is, follower axis is offset to the right side of the cam axis by 1 centimeter. So this initial position of the cam will be somewhere here at 1 centimeter. Okay, so displacement diagram will be same. But this cam profile will change. So the last part of the question is you have to find the maximum velocity acceleration during the outstroke and return stroke. So during the outstroke, the type of motion is simple harmonic motion. So you see in this formula, simple harmonic motion, type of motion is simple harmonic motion, and during outstroke you have to find the maximum velocity using this formula, and you have to find the maximum acceleration using this formula. Okay, if during in-stroke, during the return stroke, if you have simple harmonic motion, then you have to use this formula, and this formula for velocity, this formula for acceleration. Okay, now we have to make use of two formula, because we have two types of motion. During outstroke it is SHM, that is we have to use this formula, VA is equal to pi omega S by 2 theta A, where omega is equal to 2 pi n by 60. Next, during return stroke, we have uniform acceleration retardation motion, and during return stroke or in stroke we have to use these two formula. For velocity, 2 omega s by theta d, and acceleration alpha d is equal to 4 omega square s by theta d square. Okay. So here I'll write first one is outstroke, that is simple harmonic motion. Simple harmonic motion outstroke. Maximum velocity V A is equal to A in the sense ascent. V ascent is equal to pi omega s by 2 theta A, where omega is equal to 2 pi n by 60. See, this n is nothing but the average speed. This uniform speed, that is 1200 rpm. Okay, so substitute this n value, will get omega. Substitute this omega into this formula, will get maximum A. The next is alpha A is equal to pi square omega square s divided by 2 theta A square. Okay, so if you substitute here, 2 into pi into n is 1200 divided by 60. So if you calculate, it will come up to 125.664. It is in radian per second. This is omega. Okay, if you substitute that omega value in VA, so VA is equal to pi into omega is 125.664 into S is 3 centimeter. S is nothing but the stroke. It is not minimum radius, it is a stroke. Okay, divided by 2 into theta. Theta A is 120 degree. So this 120 degree you have to convert into radians, because we have omega in radians. So pi by 180 degree. So if you substitute this in calculator, you will get answer in terms of centimeter, that is 282.74 centimeter per second. Okay, we'll get centimeter because we have this S in centimeter, 3 centimeters. So if you convert into meter per second, if you want to convert to meter per second, then you will get divided by 1000, will get divided by 100 centimeter to meter rate. So 2.874 meter per second. Next, if you substitute into alpha A formula, pi square into 125.664 whole square into 3 centimeters divided by 2 into theta. Theta is nothing but 120 into pi divided by 180, the whole square. The answer come up to 53,000. Sorry, 53,295.6 centimeter per second square. If you convert, it will come up to 532.956 meter per second square. Okay, so this is your answer. This is alpha maximum acceleration during outstroke. This is a maximum velocity during outstroke. This way. Now during return stroke. That is UARM. The formula you have to use is UARM in stroke VD. D is nothing but descent. VD is equal to omega S divided by theta D, and alpha D is equal to 4 omega S, so 4 omega square S by theta D square. So if you substitute in this formula, the answer come up to maximum velocity Vd is equal to 480 centimeter per second, and if you want to convert to meter per second, it will come to 4.8 meter per second, and alpha D is equal to 76,800 centimeter per second square. To convert to meter square, 768 meter per second square. So these two are the answers. Okay, so you have to remember these formulas and you have to substitute in directly to this formula to get answers. So this much is the solution for first question, only for radial follow. Okay. Now this is a question. After that, first you have to draw displacement diagram. Next, using displacement diagram, you have to draw cam profile. Then you have to substitute in formulas to get answers: velocity, maximum velocity, and acceleration. Okay. Thank you.